Let's discuss the question number 3 from test 5, which is from industrial engineering, the operation control part. So we need to maximize a function given as z is equal to 2a plus 3b. A and b are the variables, and constraints given are a plus b should be less than or equal to 10, 4a plus 6b less than or equal to 30, 2a plus b less than or equal to 17, and a and b are all positive. So this, let me draw the constraints, because once I draw the constraints with a as on the x-axis and b on the y-axis, the variables, so the feasible region is basically bounded. We can find out the bounded region, and that will be my feasible region, and the solution of the linear programming problem lies at the corners. Okay, so now let's name these constraints as 1, 2 and 3, and let's draw that. So constraint number 1, a plus b is equal to 10, will be a straight line where a intercept will be 10, 0 and b intercept also will be 0, 10. Now constraint number 2, which is 4a plus 6b is equal to 30. For b0, a is 7.5, that is a intercept, and a0, b is 5. So now, so a intercept is 7.5 and b intercept is 5, 0. So this will be something like this. Okay, so this is all about second constraint. Now third constraint is 2a plus b is equal to 17. So when a is 0, b is 17, and when b is 0, a is 17 by 2, which is 8.5. So the constraints will be 8.5, and here let it be 0, 17 for the b. So now the line joining these 2 points, so 8.5, 0. Okay, so now my solution, the region here is bounded by these 3 constraints is basically this. Yeah, so my solution should lie at these corners. Okay, so these 5 corners. So this is basically my feasible region. Okay, where all the constraints are satisfied. And so now the solution of the linear programming lies at the corners. So now if I substitute the values of a and b related to these corners, then I should get the value, and let's find out the maximum z. So now z is 2a plus 3b. Actually, looking at this, we can say that this is, if I draw 2a plus 3b is equal to some constant line that is parallel, or in fact it is equal to 4a plus 6b is equal to 30 lines. So constraint number 2. So it's like my objective function is always parallel. The objective function is parallel to, or in fact objective function is nothing but the same as constraint 2. So at all these points it will have the same value. So let's substitute 7.5, 0 this on a node. The value of z is nothing but 2 into 7.5, which is 15. Now at this intercept, which is 5, 0, my value of z is 2, 0 plus 3 into 5, which is 15. So all these points on these lines, because constraint 2 is nothing but the same as objective function, so all these points will give me the same value of z, and this is because the objective function is same as constraint 2. The equation is same as constraint 2. So it can be seen that it has alternative optima instead of one optima. So the answer is A. Thank you.